Welcome to part 5 of our live training series here with our K24 swapped Civic Si. This training tutorial, we're going to take a look at dialing in our low cam, wide open throttle area of operation. So this is going to be out of VTEC, and this is going to be taking a look at dialing in fuel, spark, variable cam control, as well as our knock control parameters. We have a lot of things to cover here. Let's jump in so we can check this out.
Welcome back to our live training session here with our K24 swapped Civic Si. This training module, we're going to take our calibration process into our full throttle area of operation. We need to dial in our fuel, spark, and variable cam timing for our K-Series engine here. Now, we're only going to be focusing on low cam or non-VTEC tuning here in this tutorial. The next tutorial, we're going to go and jump into taking a look at our high cam or VTEC style tuning. Now, we've set up our fuel, spark, and variable cam timing tables to bias between low and high cam operations. So we actually have 2 volumetric efficiency tables, 2 spark timing tables, and 2 variable cam timing tables. And we can take a look down here. I have it open on my screen right now. We have our VE table here. This would be the main VE table we're going to be idling and driving on. That's our low cam or non-VTEC of operation. We can see right here it's on the 0 option. If we go to the 100 option, we haven't dialed this VE table in yet. This is for our high cam. Now the 4D axis here is based on our GPO15 user output, which is set for VTEC activation. It's our high side output to control and turn on our VTEC function. So we can see here if we're at 0 or not having VTEC on, we'll be on our VE table here. And if we're going to have our VTEC engaged, we'll be on our secondary VTEC table. So we have 2 tables for both spark, fuel, and variable cam. So we're going to be dialing in essentially everything here above 80 kPa on our VE table. We'll call it VE table 1 or low cam table. This is the focus of this tutorial. We're going to be using the closed loop lambda correction just as we did at idle and part throttle tuning to dial in our full throttle. It really simplifies the calibration process, and we're going to be following that exact same process here in this tutorial. Now, let's take a look at a few additional things that we need to know here besides just working within our volumetric efficiency table. We have our ignition timing table here in that last tutorial, part throttle cruise. We've dialed everything here below 80 kPa. Everything here above 80 kPa, we have it set at 15 degrees. We have a conservative spark timing here in our upper regions of our spark timing table where the wide open throttle area is going to be, because we want to be able to calibrate our knock sensor as well as dial in our full throttle. And we need to have conservative spark timing here to kind of have a 2-part effect. 1, to be able to dial in an airflow and fuel model without worrying about knock or preignition. And then 2, being able to set our knock sensitivity table that's relative to the lower spark timing where we don't have knock or preignition. That'll make a little bit more sense as we go through and start to do our full throttle tuning and set up our knock control towards the end of the tutorial. Now, that does leave us 2 different aspects, additional aspects we want to talk about here for our full throttle tuning here on low cam. If we jump in here to our lambda target table above essentially 80 kPa, we've set our lambda targets here to 86 lambda. That's a pretty conservative target lambda that we can dial everything in at. We can always go back in and change this without having to retune our volumetric efficiency table, because the lambda value here is part of our fueling equation. Fuel mass is equal to air mass divided by target air fuel. We specify the air mass coming from our airflow model volumetric efficiency table. The target air fuel comes from knowing the lambda and multiplying it by the stoich of the fuel that we're tuning. It gives us a target lambda. Then we can figure out our fuel mass and turn that into injector pulse width based on knowing the injector data supplied into the max. So it's a pretty straightforward equation of how we're working with this, but we need to specify obviously a proper target lambda to get it started. We can always go in and experiment going to a richer or a leaner target lambda mixture once we've dialed our volumetric efficiency table in to hit the desired target lambda that we program currently in the table. So that's our goal here, getting the volumetric efficiency table sorted out. Now, there is another aspect of this with a K-Series engine or any variable cam engine, and that is dialing in the variable cam control. Let's talk about that, because that's really the first thing we're going to be diving into here in the beginning of the tutorial to get that worked out. So if we jump in here to our VVT, we went in, we set up our variable valve timing control in the last 2 tutorials prior to this tutorial. And if we go here to our cam target position, I really haven't populated anything above 80 kPa. So 90 kPa and higher here, we have our variable cam target at 0. Now we're purposely running it at 0 right now so that we can build out what's known as a cam composite blend. We've went here in our part throttle and had some solid values for good drivability, good throttle response, good economy in our part throttle area. But now under full throttle, we need to figure out what is going to make the best, broadest power band or torque band possible out of our engine. We can accomplish that with the variable cam control. Now, a few things with this. As we make changes in our variable cam timing, this will affect our airflow and our torque production of our engine. So if we make more torque, we're moving more airflow, and therefore we need to add additional fueling. So this gets to be kind of a little bit complicated topic or process here, because this table will affect our fueling. So what's the best strategy here to get everything dialed in? And what I like to do is do a baseline pull when I'm at 0 degrees here. We'll see what the power output of the engine's going to be. We know we have conservative spark timing. Again, that's not a concern right now. Spark timing is the last thing that we touch in the calibration process. What we're going to do is establish what the fueling looks like under wide open throttle at no cam target or no overlap from the variable cam control. And then we're going to go into another pull and lock our variable cam timing at 10 degrees, 20 degrees, 30 degrees. Now I have a 50-degree VTC gear on our engine from a RSX.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.